Good morning everyone. Myself Dr. N. Pratyusha, Assistant Professor in Mathematics, Department of Humanities and Sciences, MLR Institute of Technology, Hyderabad. Today we will discuss about Fourier transform. It's part 3. It's under numerical methods and integral transform. This is the overview of today's presentation. So first we will discuss about what are the formulas for infinite Fourier sine and cosine transforms, and basic example will be discussed here. Okay. This is the formulas for infinite Fourier sine and cosine transforms and its inverse. The Fourier sine transform of a function f of x is given by f s of f of x. For Fourier sine transform we will mention as fs, and cosine transform we will mention as fc. So fs of f of x equal to fs of p equal to integral 0 to infinity f of x sin px dx. So the inverse is f of x equal to 2 by pi integral 0 to infinity fs of p sin px dp. So infinite Fourier cosine transform formula was fc of f of x equal to fc of p equal to integral 0 to infinity f of x cos px dx. Only the difference between sine and cosine was here in the formula where the sign will be present we will write cos. Here f of x sin px, here f of x cos px. Here also for inverse Fourier cosine transform, f of x is equal to 2 by pi integral 0 to infinity fc of p cos px dp. So if you see the example, you will understand the what is Fourier sine transform and cosine transform. Okay. Here first example was find Fourier cosine and sine transform. So here we have to find both cosine transform and sine transform for the function e power minus ax, and hence deduce the inversion. I already discussed in the earlier before presentation, if the given deduction or evaluate, so we have to find the inversion of the given function. Okay. First we will find the Fourier transform. Next we will find the inverse of that Fourier transform. Okay. The formula for the Fourier transform means first we are finding cosine, right? So we have fc of f of x. I already discussed fc means Fourier cosine transform. So this here in the problem they didn't mention finite. So that means this is infinite Fourier cosine and transform. If for finite they particularly mentioned finite Fourier cosine and sine. Okay. That's why you are using the infinite formula. So we have fc of f of x equal to integral 0 to infinity f of x cos px dx. Here f of x is, let f of x is, what is f of x? Given function e power minus ax. So I am substituting e power minus ax in the formula. I will get integral 0 to infinity f of x in the place of f of x e power minus ax I am substituting, right? So e power minus ax cos px dx. This is in the form of integral e power ax cos bx dx. The formula for e power ax sin cos bx is e power ax by a square plus b square a cos bx plus b sin bx. This is the formula for integral e power ax cos bx. Here in the place of a, minus a is there. In the place of b, p is there. So I will substitute a, b values in the formula. I will get e power minus ax. So minus a whole square, right? So a square plus in the place of b, p is there. So p square. So minus a cos px plus p sin px in between the limits 0 to infinity. So here e power minus ax term is there. So here we can write it as 1 by e power ax, right? upper limit was infinity, right? So when I put infinity, 1 by e power infinity. So 1 by infinity value is 0. So 0 into anything is 0. That means upper limit of total term was 0. So 0 minus. So when we substituting the lower limit means we will put minus, right? So minus 1 by a square plus p square. Here 1 we will get. Here e power minus ax, right? So 1 by e power ax. So 1 by e, lower limit was 0, right? So 1 by e power 0. Anything power 0 value is 1. So 1 by 1, that is 1. So I will get 1. So 1 by a square plus p square. Here I am substituting 0, right? So cos p into 0 means cos 0. Cos 0 value is 1. So similarly here sin p into 0 means sin 0. Sin 0 value is 0. So p into 0. So I will get minus into minus plus. So a by a square plus p square. This is FC of p. That means Fourier, infinite Fourier cosine transform. Here we have to find cosine and sine transforms, right? So for that I am applying infinite Fourier sine transform. So the formula was fs of f of x equal to integral 0 to infinity f of x sine px dx. So this is in the form of integral e power ax sine dx. Integral e power ax sine dx. What is the formula for e power ax sine dx dx? Already in the last session I already discussed about the formula. Again I am writing here. So e power ax by a square plus b square. A is sine bx minus b cos bx. In the place of a here minus a is there. In the place of b, p is there. So I am substituting a, b in the formula. I will get e power minus a by a square plus p square minus a sine px minus p cos bx in the limits 0 to infinity. So I already discussed now only. So again I am discussing here e power minus ax term is there. So we can write it as 1 by e power ax. We substitute upper limit 1 by e power infinity. So that is 0. That means when you substitute upper limit, the term will be 0. 0 into whole term means 0 into anything is 0. The first term will be 0. So next we will apply second limit. So that means lower limit. When we apply lower limit, we will put minus, right? So minus 1 by e power 0. Anything power 0 value is 1. So 1 by 1 is 1. So that's why here 1 term is came. So 1 by a square plus p square. So minus a into here I am applying 0, right? Sin p into 0. So sin 0 value is 0. That's why minus a into 0. Here cos p into 0. Cos 0. Cos 0 value is 1. So minus p into 1. So here minus into minus plus. Minus into minus plus. That means I am clearly writing here. Minus 1 by a square plus p square. This term is 0, right? So 0 minus means minus p. So minus into minus p. Minus into minus p is plus p. So p by a square plus p square. This is the infinite Fourier sine transform. So first part we are completed. Means we are finding infinite Fourier cosine transform here and infinite Fourier sine transform. Next we have to find the inversion because to deduce the integral. So now by the inverse Fourier cosine transform, the formula was f of x equal to 2 by pi integral 0 to infinity fc of p cos px dx. Already we find the fc of p here. So we will substitute fc of p in the formula. We will get f of x is e power minus ax, right? So e power minus ax equal to 2 by pi integral 0 to infinity. In the place of fc of p, I am substituting a by p square plus a square. So cos px dx. So here, so we will get a is constant, that's why I am writing it outside. So here we will get e power minus ax equal to 2a by pi integral 0 to infinity cos px by a square plus p square dp. Here what they given, we have to deduce the integral cos integral 0 to infinity cos px by a square plus p square dp. So that's why I am taking this constant into the left hand side. So I will get integral 0 to infinity cos px by a square plus p square dp value as, here it will be reciprocal, right? So pi by 2a e power ax. Therefore, they will not mention the deduction. We need not to find the inversion. If they mention, we have to find the inversion also. So similarly for the inverse Fourier sine transform, because they given integral 0 to infinity p sine px by a square plus p square dp, right? So for that we have to find the inverse of the infinite Fourier sine transform also. So the formula for inverse Fourier sine transform was f of x equal to 2 by pi integral 0 to infinity fs of p sine px dp. So here fx is e power minus ax. So 2 by pi, here we already derived fs of p using infinite Fourier sine transform. That result was p by a square plus p square. We are substituting in the place of fs of p. So we will get 2 by pi integral 0 to infinity p by a square plus p square sine px dp. So they given, we have to deduce, this is right, integral 0 to infinity p sine px by a square plus p square dp. So that's why I am taking the constant into the left hand side. I will get pi by 2 e power minus ax. This is the result of this example. First we find the infinite Fourier cosine transform, and next we find the infinite Fourier sine transform. They given the reduction, right? Means they have to given in the deduce the integral. For that purpose we are finding the deduction using the inverse Fourier sine and cosine transforms formula. You proved the result. Okay. In today's session we have discussed about the infinite Fourier sine transform, infinite Fourier cosine transform. Based on this formula, you discussed about the example. In next session, we will discuss about the finite Fourier sine transform and finite Fourier cosine transform, and based on this formula, we will discuss about the example. Okay? Thank you.